we don't want to use up all our time. You said you're doing probability questions, is that correct?
Yeah.
Okay. Let's start out with just a basic question. Let's say the probability of rain is 0.23. You remember from class what the probability of not rain would be, or how to figure that out?
Wouldn't it just be like 7.7?
It'd be 1 minus 0.23, which is 0.77, like that.
Yeah.
All right, cool. Can you think of some other questions that you might have seen in class? Okay, like for example here, a jar of marbles is kind of a common, like let's say there's 4 blue, there's 3 red, and then there's 2 white and 1 orange. What's the probability of selecting a blue marble? Do you remember that from class?
Yeah.
Okay. What would that be?
So a blue one would be
Basically, it's how many blues are there out of how many total?
you have like a 4 in 12 chance.
Go ahead and add those up one more time.
Oh shoot. 4 in 10, so like a 40% chance.
Okay, so that is fine. 0.4 or 40%, that's good. What if you wanted it as a fraction? What would be the answer to that?
2/5.
2/5, yeah. So all of these are correct. 2/5, 0.4 or 40%. Okay. Now, did you talk about what would happen if you wanted to, the probability of like 2 blue marbles? So the probability that the first one is blue times the probability that the second is blue. So we already know the first one, 4 out of 10. But what about the second one? You remember that?
Would it be 2 out of 10?
Well, assuming you selected a blue marble, how many blue marbles are left?
Oh, 3.
3. And assuming you took a marble out, there's no longer 10. How many are in here?
9.
9. Okay. Now the reason you multiply is because it's an and situation. It's an and situation. So I don't know. Does it seem like stuff you've been doing, or is it not?
Yeah.
Okay. Could you multiply these together for me, please, and reduce as much as you can?
Yeah. Um, you'd have a 1/3. So one
But you're
third.
multiplying. You're multiplying.
Yeah. 4 and 30. 12 and you'd have a 4 and 30% chance.
Just give me the fraction. Let's start with the fraction. What would the fraction be?
12 over 90.
Okay, but you got to be able to reduce that. So that's maybe something we'll work on here, because the best way to do it is to reduce these numbers as much as you can and then multiply.
Okay. So 2 over 5 and then 1 over 3. 2 over 15.
So we got 2/5, yeah, 2 over 15. Good, very good. Okay. All right. So let's do the same scenario here. And let's do the probability of a red times the probability that the second one is blue. So first red, second is blue. So see if you can figure out what that becomes, please.
Mhm. So you got it. 2 over 15 times 4, 2 over 5. That would be 4 over 75. So it's you have a 1 in 25% chance.
Let's be careful there. So is your final answer 1 in 25?
Uh,
So
yeah,
what, give me first, what's the probability of red? What does that become?
40%.
Just give me the fraction that you don't want to be giving me percentage, just the fraction. 4 out of, okay, now what about the blue?
That would be 2/15.
But how many blue are there?
Oh, 3.
How many blue are there? You didn't choose a blue, you chose a red first. How many
Oh,
blue? How many blue are there?
oh, there are 4.
Okay. And so I'll let you talk me into this, but there's only 3 red. There's only 3 red. Now, after you've chosen a red one, how many total marbles are there?
There are 9.
Okay. So this time you have to reduce this. Now, you can reduce not diagonally, but like you can imagine the 3 is really above the 9 and the 4 is above the 10. That's okay.
Mhm.
So again, why don't you reduce this for us, please?
Okay. 1/3. 2 is 2/15.
2 over 15 again. Okay, good. Let's try another one here. We're doing better here. Doing better each time. All right. What's the probability that the first is a white? Probably the second is a red.
Um, probably. So you would just multiply.
You have to first figure out the white and then the red. Okay.
Oh,
Just
okay,
like we did in the previous problem.
okay. So you have
So how many white out of how many total? Then how many red out of how many total?
okay. So 1/5 times 1/3 is 1/15.
Is that your final answer?
Uh,
I'm just asking. I'm only asking just because I haven't worked it out yet. I'm just making sure that's what you want.
yeah.
2 out of 10, 3 out of 9. Yes, that is correct. Good. Okay, let's look. Um, let's look at a different type of problem here. Actually, let me back up. We'll do one more of these because that will help lead into this. What is the probability of choosing just a white? What would that be in this problem?
Just a white
Just a white.
be 1/5, 1/5.
Okay. So it's okay to say 2 out of 10, which reduces to 1 out of 5. Perfect. All right. Here's a new problem. So this is actually just like the marble problem, except instead of marbles, it's caramels, mints, and dark chocolates. Will you try this problem on your own, please?
Yeah. Mint as a fraction. So you have 45 mints and wait. 35, 7 is 1/4. You have a 1 in 4 chance.
You said 1 in 4, 1 out of 4. Is that right?
Yeah.
Okay, so probability of selecting a mint. How many mints are there?
There are 7.
And how many total candies are there?
35.
Okay. So this is correct, but this is not.
Uh-oh.
So try that one more time, please.
Oh, it's a 1 in 5 chance.
Now you gotta be careful with what you're saying. It's 1/5. The 1 in 5 could mean something else depending on the course you're in. So just be really careful with your language. Because it really does matter. Really, really, really does here. So
Mhm.
all right. So one of the next problems we might see here is it says a letter is randomly chosen from the word television. And the first thing it asks you is, well, how many letters are there in the word television? Well, what you really want to do is make a chart here. There's T, there's E, there's L, there's V, there's I, there's S, there's O, and there's N. See how these are all different? And you want to put the counts in, like how many of each are there? How many T's, how many E's, L's, V's, I's, S, O, and N's? So could you do that for me, please?
Yeah. So there are 1, 2, 3, 4, 5, 6, 7, 8 letters in television.
No. I want you to count how many T's, E's, so on.
Oh,
And
okay.
like there's 8 unique letters, but the word itself has more than 8 letters in it, which is a small distinction, but it's an important one.
There's 1 T, 1 P, 1 L. So wait.
I'm asking you to count the number of T's, the
Uh,
number of E's, and give me those numbers here.
isn't there one of each?
No,
No? Oh, okay. 1 T, 1 E, 1 L, 1 B, 1 I, 1 S, 1 O, 1 N. Huh? 11.
Max, this is not meant to be complicated. I'm just asking you to count how many T's are there in this word.
1.
Then, okay, how many, and then how many E's?
1.
No,
E's?
yes. Let me highlight it
Oh,
here.
like in the act, not in the diagram?
No, in the word.
Oh, okay. So there's 2 E's.
Okay, so now I don't give me any more letters. Don't give me any more numbers. I want you to finish this table off and then tell me.
Okay. 1 L, 1 B, 2 I's, 1 S, 1 O, 1 N. Would it be there's 1 L, there's 1 V, there's 2 I's, there's 1 S, there's 1 O, there's 1 N?
Very good. Now, if you add all of these up, how many are there total?
Uh,
Or you can just count in the word. That's okay too.
huh?
How many letters are there in the word television?
8,
No,
9.
you're just counting or you're adding up these numbers.
Oh. 3, 4, 5, 6, 7, 8, 9, 10.
10. Okay, so the answer is 10. Okay, and it's broken down as, like you said, 1 T, 2 E's, 1 L, 1 V, 2 I's, 1 S, 1 O, 1 N. Okay. The reason we did all this, I know it might be like, why are we even doing this? Is because we're going to use these counts in the next problem. Okay. So actually, I'll just do this by hand. So the next thing here is the probability of selecting a V. The probability of selecting a V is the number of V's out of the total.
Mhm.
So how many V's are there?
One,
Out of how many total?
10,
Okay. What's the probability of a vowel? A vowel. So you got to remember your vowels. Do you remember your vowels from,
yeah.
okay,
So I just count out all the vowels.
yep,
2, 4, 5,
out of,
10,
is this your final answer?
9.
Say that again?
9?
No, I'm asking you, if you put, so when I prompt you, that means there's probably something you're missing. This fraction is not reduced.
Oh, 2/5.
Nope.
1/2. Sorry, my
One
bad.
half. Yeah, that's okay. All right, how about the probability of E? What is the probability of E?
The probability of E is 1/5.
Okay, what's the probability of not E?
4/5.
So you did this earlier.
No.
Probability of rain, 0.23, not rain is 1 minus. So not is the word not, you always want to think of it as 1 minus.
Mhm.
So not E is 1 minus 1/5. What does that become?
1 minus 1/5 is just 4/5.
4/5. Okay. All right. So now, like, I don't have a ton of room here. What's the probability of not S? Not S.
Not S is is 4/5.
Okay. Tell me what's the probability of S?
1/10.
Okay. So how did you come up with 4/5? And don't tell me you just thought it was the same as this.
Okay, I'll come with something other than that.
So it should be 1 minus 1/10.
1 minus 1/10 would be 9/10.
Okay. All right. So let me make another one up here and see if we can do this. Let's say that A, sorry, let's do A, let's do a count B and C. All right, what's the probability of A?
Probability of A would be, so there's 2/10, 1/5.
Okay, so 4 out of 20, which is 1/5. So what is the probability of not A?
4/5.
Okay, good. What is the probability of not B?
Not B. Oh, 7/10. So it would be 3/10.
3/10, good. Okay, I think you've got it. I think you've got it down. All right. So let's look at a couple of questions here. I'm going to give you a new table. All right, so I want you to read this and tell me the answer to A and B after you kind of read it and look through it. Let me know if you have any questions.
Okay. Mhm. Two heads occur. 36 times. What's it fewer than 2 heads? 52 times. 51 times.
right, so I heard these answers. These are both correct. Now notice that these are not probability. Okay, they're just counts.
Yeah.
Okay. Could you give me the total here? The total frequency?
Yeah. So you got 49, 60, 100.
100. Good. Okay, so that's really important for answering the next part of this question here. I'm going to snip this in, and I want you to find all four of these. I'm going to step away for like a minute here, but see if you can work these out. I'll be right back with you.
Okay. One 11 out of 100, and then you got two heads, 36 out of 100, which is 15, 16, 17, 18 out of 50, which is 9 out of 25, 9 out of 25, right? And 225. Fewer than two heads. 51, right? 51 over.
I am back. Let me know if you have any questions.
Okay. And then at least one head. So when it says at least one head, does it mean the smallest amount of heads is one, but it could also be 2 and 3?
Question. You're thinking about what does it actually mean?
Okay. So it would be 76, 80, 89. So 89 out of 100.
Whenever you're ready, if you want to give me all of the answers, I heard this for the last one.
So fewer than two heads would be 51 over 100.
Okay, good.
And then two heads is 9 over 25.
Okay, that's correct. Good job reducing that.
And then 0 heads is 11 over 100.
Perfect. Okay, really, really good. Looking for some more questions. Did you guys talk about Venn diagrams?
Yeah.
You did. Oh, fantastic. Okay. Let me just throw up. Well, that sounded bad. Let me put up a question based on a Venn diagram here. We'll just do this slowly. So here's a Venn diagram with these numbers. Could you give me the probability of A and then the probability of B based on what you see here?
Probability of A would be 3 over 10.
How did you come up with 10?
Because, oh shoot, 9.
Okay, so let me color code what the probability of A is. They sometimes do this in courses. It's everything including the overlap. So do you want to change your answer?
Everything including the overlap.
Is this because this 2 is part of A?
Oh, so it wouldn't be 3, 2, and 4, it would just be 3 and 2.
Yes.
Okay, so it would be 5.
Out of
9.
or 5/9, good. And then B is the same way here. Draw the picture here in case you want to look at that later. It's everything including the overlap. So what would that be?
That would be 6/9 of 2/3.
Okay, good. Now, did you talk about things like A and B? Which is really the overlap?
No.
Okay, that's fair. So the overlap is right in the middle here. That's 2/9. Did you talk about A or B? A or B? Yes, no, maybe.
A vague recollection of that, like A
Okay,
and B or A and B, but not in like the Venn diagram.
right. So this one's a little bit harder. It's all three numbers. So it ends up being one. This again, this is not to, I'm not trying to come down. It's just that this is good for, this is why we want to have the notes. So I know, so I'm not asking you questions about things you don't know. All right, so here's what I want you to do. This is our next problem here. We're going to build a Venn diagram. All right, so here we go. Here's your Venn diagram. A, B. So I'm looking for the letters, and I'll just do different letters. So we'll go X, Y, Z, and W. So I'm looking for those values. Some may be 0, but I want you to read this and tell me what those are. You may have to work it out. You may have to do a subtraction or add, something like that.
Okay. It will be so there are 15 hockey players. 15 hockey players at a game of hockey. 13 played on the field, 7 sat on. Wait. Okay. That makes sense now. So 15 players. 7 sat. "13 played, 5 sat and played." All right. So you would have
You want a hint?
I think I might get it,
Okay. Sounds
but
good.
probably not. I think it would be like 2 sat the whole game.
So here's what I'm looking for, Max. I'm looking for you to say like X equals, Y equals, Z equals. These are numbers, W equals. That's what I'm looking for. Tell me which numbers go in each position.
Let A be the event the person played on the field. So B would be, so Z equals 2,
Okay.
and then X equals 8,
Okay.
and then Y equals 5.
How about W? What does that equal?
W?
Yep.
Oh, 0?
Yes. Good. So this is correct. So the hint is to do this one first. Both.
Oh, okay.
That's gonna make this the easiest. So
Mm.
all right. We are basically out of time for today. So I'm just gonna go ahead and stop here rather than try to get another question.